Chairman. I am Mr. Kita from Odor Science Laboratories. My presentation agenda is like this. Then my self-introduction. I work for many years Siemens Corporation, where since 1994 I have been engaged in the development of electric nodes. In 1999, I launched the first generation of FF1 and subsequently developed the two later generations. After leaving Siemens, I found the Odor Science Laboratory, where I developed electric nodes and provide contact analysis, consulting, and seminar instruction. I would like to share my thought. At the root, as a suggestion by the table 1, lies a fundamental misunderstanding of the nature of odor. I listed 5 fundamental issues that stem from this misunderstanding. According to them, the most important are: number 1, insufficient sensitivity; number 2, the VOC issues. On the other hand, I would like to address why the electric nodes are necessary. Beyond simplicity, beyond simple quantify odor, I have a more fundamental expectation to prove the mystery of mixture odor. In this figure, when the green odor is mixed with a vanilla flavor, the result is not a green vanilla smell. Instead, it becomes a pleasant aroma as if vanilla had acquainted a hint of lime. The central panel shows in vitro observation of human olfactory receptors response on this case. As you can see, that the aroma A plus aroma B is in practice not simply A plus B. This suggests that the mixture mystery may arise not in the brain central processing, but already at the level of receptor responses. Then the component separation analysis, such as TC mass, cannot capture this behavior, whereas electric nodes may able to approach and characterize this phenomenon. Now let us dig deeper in the problem of insufficient sensitivity in odor sensor device. This figure plots the several odorants, their olfactory detection threshold concentration. When we overlay the typical sensor detection limit of many odor sensor modalities, it becomes clearly that for many malodor components, sensitivity falls far short of the olfactory threshold. Now let us consider limit of the detection. This suggests that the absence of the application mechanism intrinsic in the sensor, the range may respond a theoretical detection limit. By an interesting application mechanism, I mean something like field effect in the LVT. In the case of metal oxide semiconductor sensor, if we regard green boundary as a gate and the electrode current as analogous to the source drain current. Human olfaction appear to be amplification as well. If the olfactory receptor response is considered the gate, the calcium ion channel, the source drain current, this constitutes an amplifying process, which may help explain the high sensitivity of smell. Moreover, paper published this May by Professor Tohara's group at the University of Tokyo represents fibrinectin in the olfactory mucosa can effectively increase the local concentration in coming odorant, functioning like concentrators. There, the VOC typically have higher olfactory detection threshold, even when they exist in greater amount than the odorant in interest. They are scarcely perceived, so people seldom notice them. This setup mount 8 of Bosch BME 688 sensors. BME 688 form thin film metal oxide. Although the 8 devices are nominally identical, the on-die microheater allow low thermal mass sensing film to be temperature modulate very quickly, and you can drive 8 sensors in four different heater profiles. Because metal oxide semiconductor sensor exhibit markedly different gas response character at different operation temperatures. In both Bosch's application video from this device, the procedure was first measure the background in ambient air at 3 minutes, then placed the sensor in the container with coffee A and made 3 minutes. Watching the neural network result shown below indicate it can distinguish only coffee or coffee not. It cannot distinguish coffee A, distinguish coffee A to B. That is because if the coffee head space were presented in the clean air, most array might manage to resolve the difference between coffee types. But when the coffee aroma is present within the VOC laden environment, This intercopy difference could be masked by the ambient VOCs. So we try to experiment. I purchased commercial available Guatemala and Colombia blend coffee, then in the glass jar. For the left-hand measurement, including background, I measure in the ordinary ordinary ambient air. For right-hand of measurement, also include the background. I reduce the coexisting VOC in glass vessel, introduce the high purity air at 30 milliliters per minute, therefore, through the PTFE tube. The evaluating the neural network classification on two coffee types, I found that removing ambient VOC markedly increased classify separately, supporting the consideration that the coffee distinguished after removal, VOC removal. Looking at effect, I'd like to consider the direction of electric node technology. Taking cue of the e-nodes we developed CMAS. In the instrument, insufficient sensitivity was addressed by integrating preconcentrator. And the influence of the ambient VOC was mitigated by placing a sample in the sample bag and measuring it under high purity nitrogen or air. In addition, multiple reference gas of sensors were treated as the multiple reference gas was used to compensate the sensor drift over time. For analysis, output of multiple sensors were treated as a vector. Vector length corresponds to the odor intensity, and the vector direction corresponds to the odor character. Furthermore, we adopt a model-based rather than the learning-based approach. The method avoids the need for the large amount of training data. Using this system, 7 sample wasabi and wasabi live product were measured. Left graph represents each sampled odor intensity as an odor intensity equivalent, odor index equivalent, while the right graph take the number 1 to be the genuine wasabi and report as a similarity how closely the amount of aroma of the each other sample matches that of the sample 1. Building our own foregoing, I would like to propose 2 near directions for electric nodes. First, portable sensor with tightly defined application scope, so that issues such as VOC interference are avoided and device remained usable even with a small number of sensors. Second, more general purpose system that incorporate all functions of the SHIMA's E-node, such as odor concentration, pre-concentration, while being made contact as possible. If ideally down to the side of the laptop. Thank you for listening. If you have any question, please use this email address. That's all. Thank you.